So here we have some missing fraction problems, but we solve these in the same way that we solve missing number problems for whole numbers. So first we have 1 and 1/7 minus something equals 2/3. So it's the second number in the subtraction or the subtrahend that's missing, and that means that we still need to use subtraction to find our missing number. We need to work out 1 and 1/7 minus 2/3. Now 1 and 1/7 is the same as 8/7 because 1 times 7 is 7 plus 1 is 8, and the denominator stays the same when we change it to an improper fraction. But our denominators need to be the same before we can subtract. 7 isn't a multiple of 3, but the lowest common multiple of 3 and 7 is 21. So we can change 8/7 and 2/3 into equivalent fractions which have a denominator of 21, because when our denominators are the same, we'll be able to subtract the fractions. Now 7 times 3 is 21, and what we do to the denominator, we do to the numerator as well. 8 times 3 is 24. Now 3 times 7 is 21, and 2 times 7 is 14. So we can rewrite our question. Instead of 8/7, we can write 24 over 21, and instead of subtracting 2/3, we can subtract 14 over 21. So now that we have a common denominator, we can subtract our fractions. The denominator stays the same in our answer, and 24 minus 14 is 10, so our missing fraction is 10 over 21. And that makes sense, because 1 and 1/7 is the same as 8/7 or 24 over 21, and 2/3 is the same as 14 over 21. So if we have 24 over 21 and take away 10 over 21, we get 14 over 21 as our answer. Now we have something minus 3/8 equals 5/7. So this time it's the first number in our subtraction, or the minuend, which is missing. So we use the inverse operation, we use addition to find our missing number, because remember, subtraction problems can be read backwards as addition problems. So we can work out 5/7 plus 3/8. But to add fractions, we need the denominators to be the same. Now the lowest common multiple of 7 and 8 is 56, so we can find equivalent fractions for 5/7 and 3/8, which both have a denominator of 56, because when the denominators are the same, we'll be able to add our fractions. Now 7 times 8 is 56, and 5 times 8 is 40. 8 times 7 is 56, and 3 times 7 is 21. So instead of 5/7, we can write 40 over 56, and instead of adding 3/8, we can add 21 over 26, because that's equivalent, that's a fraction of the same size. So now the denominator stays the same in our answer, and 40 plus 21 is 61. So as an improper fraction, our answer, or our missing number, is 61 over 56. That's 1 and 5 over 56 as a mixed number, because 1 times 56 is 56, and then we add 5 to get 61. Now we have 1/3 plus something equals 1 and 1/5. So here we have a missing number addition, and whenever we have a missing number in an addition problem, we always use subtraction to find our missing number. So we need to work out 1 and 1/5, which is the same as 6/5, and we need to subtract 1/3 because we have a missing number addition. Now to subtract fractions, we need our denominators to be the same. The lowest common multiple of 5 and 3 is 15. So we can change 6/5 and 1/3 into fractions which have a denominator of 15. 5 times 3 is 15, and 6 times 3 is 18, 3 times 5 is 15, and 1 times 5 is 5. So we can rewrite our question. Instead of 6 fifths, we can write 18 fifteenths because that's equivalent, and instead of subtracting 1/3, we can subtract 5 fifteenths. So now our denominators are the same, so the denominator stays the same in our answer, and 18 minus 5 is 13. So our missing fraction is 13 over 15. And that makes sense, because remember, 1/3 is 5 fifteenths. If we add 13 fifteenths, we get 18 fifteenths, which is the same as 6 fifths, or 1 1/5. Thank you so much for watching. I really hope that was helpful. If you're a teacher or a parent, then please subscribe or go to keystage2maths.com to download resources for this lesson and many more. That's all for now. I'll see you in the next video.